Okay, this is the today's agenda. So in today's class, we are going to discuss about what is this abstract class and what are the differences between abstract classes and interfaces and what is the use of instance of keyword and what is the use of and the purpose of the final keyword. So these are the things we are going to discuss in today's class. Now first let us see what is this abstract class and what is its uses. Now let us discuss about this abstract class. So what is this abstract class? So you know what is abstraction basically. So what is the meaning of abstraction? What is abstraction? Abstraction refers to the act of representing essential features without including background details or any other explanations. So this is what exactly known as uh, abstraction. You know the meaning of abstraction. So abstraction refers to the act of representing essential features. So without including any background details or explanations. So this is called abstraction. Okay, that is abstract is a term. It is coming from the concept of this abstraction, one of the feature of object-oriented programming. So this is one of the essential feature of object-oriented programming. So now in which um, we can represent only essential features. Essential features in the sense only required things only are to present without giving any background details. What is happening in the background? So there is no. It is not necessary to represent it. Okay. So that is called abstraction. Similarly, an abstract class. So what is class? We know. So a class basically includes data members and the methods and constructors actually. Okay. So now an abstract class means it is a class. Basically, abstract class is a class basically. So that contains abstract methods or that contains at least one abstract method. At least one abstract method. So what is abstract method here? That is if a class contains at least one abstract method, then we call it as an abstract class. Okay. So if it contains at least one abstract method, then the class is known as abstract class. Okay. So what is abstract method? Abstract method is a method without implementation. Okay. So abstract method is a method without implementation. That is the method that contains only body. That is the signature or the header of the method only. So without any implementation. So now later on, if you want to provide the implementation for this, so you can provide your own implementation. That is, some methods are there. So these methods are common to some classes, are common to some subclasses. Now a subclass can provide the implementation according to their requirement. Now, in such case, what we can do is, so leave the implementation to the developer or the subclass so that the subclass can provide the implementation for the abstract methods. Okay. So that is an abstract method is a method without implementation. Okay. So that is called abstract method. So now, if a class contains at least one such method, so such a class is known as the abstract class. Such a class is known as abstract class. Okay. Now, similarly, an abstract class so also contains abstract class also contains concrete methods. Abstract class not only contains abstract methods, so but it also includes concrete methods. What is a concrete method? The concrete method means methods with full implementation. Okay. So that is an abstract class contains both abstract methods and the non-abstract methods. Okay. Both abstract methods and non-abstract methods. Okay. That is methods with implementation and methods without implementation also. It includes. Okay. Such a class is called the abstract class. Okay. So, and another important point related to this abstract class is so abstract class also contains abstract class contains instance variables and constructors. Okay. So another important point here is abstract class contains constructors as well as it also includes instance variables. It has instance variables and constructors. It can also include constructors and instance variables. So whereas in the case of interfaces, if we consider interfaces, so interfaces it does not include instance variables because it consists of only final and static variables. Interfaces does not include instance variables. It has only final and the static variables. So whereas and similarly, interfaces does not include constructors. Okay, but an abstract class contains a constructor. And one more important point is abstract class cannot be instantiated. Okay. Abstract classes cannot be instantiated. So what is this meaning? Cannot be instantiated means so we cannot create object for an abstract class. Okay. So you cannot create object for an abstract class. So why? So why? Because there is no use because the abstract class does not include the implementations for all of its methods. Okay. So that we cannot create or instantiate the abstract classes. Okay. So these are the major important points related to the abstract class. So this is what the essence of the abstract class. So what is abstract class and what are its properties? So abstract class means if a class contains so at least one abstract method that is a method without implementation. Such a class is known as the abstract class. So if a class contains at least one abstract method, then the class must be declared as abstract class. And similarly, if a class is declared as abstract class, then it must include at least one abstract method. Okay. So, and another important property of this abstract class is, so it contains both abstract and non-abstract methods. Contains both abstract and non-abstract methods. So, and next one is the abstract contains instance variables as well as the constructors. An abstract class contains instance variables and constructors. Similarly, we cannot instantiate the abstract classes. Okay, so this is the preliminary information about the abstract class. Okay, so now we'll see more information about this abstract class. So abstract class provides basically it is a base class from which other classes extend. Okay, suppose if you want to declare an abstract class or a common class, okay, so that common class can be known as that common class is known as the base class. This class is known as base class. So from which other classes extends. Okay, that is derived classes extends the base class. Okay, so this base class is here is the abstract class. Okay, and another important point here it is abstract classes can provide two things as we told in the beginning. So abstract classes can provide implemented methods. Abstract classes provides implemented methods. Are implemented methods, those that are fully implemented. Okay, those that are fully implemented. That is, it has the full implementation of the method. Okay, so directly there is child classes can use them. Okay, if a class extends this subclass, abstract class, now the subclass can directly use this implemented methods. And the second component of this abstract class is it includes pure abstract methods. That is those that have no implementation. Okay. Another second important component of this abstract class is so methods without implementation. So such methods are the abstract methods. That is abstract class includes both abstract and the non-abstract methods. Okay. So if it is an abstract method, these abstract methods need to be implemented by child classes. Okay. Child class must provide implementation for the abstract classes. Okay. So this is another important point. And the next one is the abstract classes will not allow construction directly, but you can create a subclass or a static nested classes to instantiate them. So this is what we have discussed. That is, abstract classes cannot be instantiated. Abstract classes cannot be instantiated. That is, you cannot create object for the abstract classes. Okay. This is the thing we have discussed in the previous slide. So now an abstract class provides a base class actually. So from which other classes extract. Okay. So this is what and these are the two important components. So implemented methods and the abstract methods. So two things are there. And the third point is the abstract classes cannot be instantiated. So that is point number 20. So now an abstract class. So must be defined by using the keyword abstract. So now how to define an abstract class. Next important point is how to define an abstract class. So now to define an abstract class, we have a keyword. So what is that keyword? Abstract. There is a keyword called abstract. Using the keyword abstract, so you can define an abstract class. That is before the class name, simply include the keyword abstract. Okay. So then once a class is abstract class, so cannot be instantiated. Okay. A class cannot be, an abstract class cannot be instantiated into objects. So what is its meaning? So we cannot create object for abstract class. This is what we have discussed. And we can have local declared variables. That is, an abstract class can have instance variables. An abstract class can have instance variables. And similarly, an abstract class can have method definitions and its implementations. Okay, that is concrete methods. An abstract class also includes concrete methods. So what is a concrete method? Method with implementation. Okay. Now once an abstract class has been declared, so it must be subclass. It must be subclass. That is, you need to create a subclass for this abstract class. And the subclass extends this. So for class that is abstract class and provide the implementation for all of its abstract methods. Okay. So that is you need to extend the subclass. You need to extend the subclass. So that is rather than implementing like your interfaces. So you need to extend the subclass. That is unlike normal classes. So we cannot create instance of an object class. Okay, an abstract class. So this is what important point we have to highlight here. So abstract classes cannot be instantiated. This is the important point here. Okay. So and more information about this abstract class. So if a concrete class uses an abstract class, so it must inherit it. That is, if the concrete class means subclass. If there is a subclass, if the subclass wanted to use this abstract class, okay, so then it must inherit the abstract class. So this is one important point. And another important point is abstract classes are important. So when all derived classes should share certain method. Okay. So for example, there is a class shape. There is a class known as shape. There I want to calculate area. I want to calculate area of circle, area of rectangle, area of triangle, like that I want to calculate. Okay. So then what you have to do is, so you need to create one abstract class. There, write one method called area. Now the circle class can provide implementation in its own way, and the rectangle class provides its implementation in its own way. Okay. So like that, in this area method is shared by two different classes, two different subclasses. So in such cases, so we can go for these abstract classes. Okay. So this is an alternative to use an interface actually. So when you subclass from an abstract class, so you are forced to implement its abstract methods. This is the very important point here. Suppose that if an abstract class contains two methods, if an abstract class contains two methods, now all of its two methods should be implemented. Okay, in its subclasses. Okay, in its subclasses. So this is the important point we have to remember. Right. So this is regarding this information about the abstract class. So there is no rule actually to go for this, either abstract class or interface. So depending upon the situation or the usage, so you go for this either abstract class or interface. Okay. So generally, an abstract class is used when a strong relationship between itself and the classes. So that will be derived from it than interfaces. Okay. So now classes and interfaces can implement multiple interfaces. So whereas a class can only be subclass of one abstract class. Okay. Suppose if you go for these interfaces, now a class can extend or implements multiple interfaces. So, but whereas a class can extend only one class. Okay. So abstract classes allow methods to be defined. Okay. So in general, when you go for this class, abstract class, and then we should go for this interface. Okay. Now, abstract classes often have a relationship called is a relationship. Okay. Abstract classes have is a relationship. So, what is a relationship? Suppose there is a class person and there is another class student. Okay. So now student is a person. Student is a person. So that what you have to do is student is a person means so person may be better as an abstract class. In such case, what you have to do is define this class person as an abstract class instead of going for interfaces, because these abstract classes often have a relationship known as is a relationship. If a student is a person, then go for person as an abstract class instead of going for interfaces. Okay. So, and another thing is interfaces often have. If you go for interfaces, so it has a relationship. Interfaces have has a relationship. That is, if you consider this example, the vehicle has a engine. Vehicle has engine. So now in such case, declare this vehicle as an interface. Okay, that is engine as an interface. So because engine may be declared as an interface rather than class. So because vehicle has an engine. So it is a relationship known as a relationship and is a relationship. When there is a relationship, go for abstract class. When there is has a relationship, go for this interface concept. Okay. So this is the thing about the abstract classes. Okay. So what is abstract class? So what is when you go for this abstract class and what are its properties? What are the properties of the abstract class? So now let us see some examples of this abstract class. Okay, this is what we have seen. So what is abstract class? Okay, so what are its properties, right? So now let us see how to declare an abstract class. Okay, how to declare an abstract class. So what is the syntax to declare an abstract class? Okay. So in general, what you have to do is use the keyword abstract, then use the keyword class, and then write the class name. So like your classes. Okay. Now this includes abstract class includes variables. Whatever the local variables or instance variables you want to add, you can add variables, and then you can write abstract methods, and it also includes concrete methods, abstract methods, and concrete methods, and also it includes some constructors. So if required, you can also write the constructors. Okay. So this is the general form of this abstract class, way of declaring an abstract class. Okay. So to declare an abstract class, what we should do is so simply use the keyword abstract. Use the keyword abstract in front of the class name. So then use the class declaration syntax, that is class name. Again, class is a keyword and this class name is an identifier. Okay. So then write whatever the things you want to include inside this abstract class. You can declare instance variables or abstract methods or non-abstract methods and constructors. So what are the things you want to enclose in this particular class you can add. Okay. So that is abstract class name. Okay. So next, suppose if you want to write one example, suppose ABS abstract. Okay. So class, write one class known as figure. Write one class called figure. Now here you can declare one abstract method, suppose. I want to write one abstract method, abstract double area. I want to calculate area and double D1 gamma D2. Okay, there are two instance variables. I want to initialize D1 and D2. Okay, so and one method called figure, one method called area. Okay, one method known as area. Okay, so this is declared as an abstract class. Figure is declared as an abstract class. Okay, so that I want to define two of its subclasses. Okay, I want to define two of its subclasses. Right, rectangle is one class and circle is another class. Okay, this rectangle is one class and the circle is another class. These two are the subclasses of this figure class. Okay, subclasses of this figure class. Okay, so now this rectangle class implements the area to calculate the area of rectangle, and circle class also provide implementation for this class, that is area. Okay, so here what it can do is, so it is going to define in its own way. Suppose both the classes wanted to share the common information. Okay, common information. That is common information means common method, that is area method. So that rectangle class and the circle class, both the classes wanted to share this particular method, share this particular method. So that they can use it. That is class rectangle extends figure. Right. So this is what how to declare an abstract class, that is using the keyword abstract keyword. So we can declare an abstract class like this. Okay, an abstract class also contains abstract methods and non-abstract methods, that is the concrete methods, or some constructors also you can include. Okay. So now let us see some examples which illustrates the use of this abstract classes. Okay. So for example, let us take one abstract class. So abstract class A. So here you can write one method called one concrete method, that is show method, system dot out dot println. So this is concrete method. Concrete method means with implementation. Okay. And another method abstract void display. Now this is the abstract method. This is one abstract method. Now write one class B. This class B extends A. Then you need to provide implementation for its abstract method display. It's an abstract method display. Now this method, this is abstract method. This is abstract method. So class B extends this abstract class A and provide implementation for this abstract method. Okay. Implementation for abstract method. Okay. And then this is the class B implements this abstract method display. So then invoke B equal to then B, create object for B. Now B dot, now invoke the two of its methods, show and display using object of B, that is B dot show and B dot display. B dot show and B dot display. Now suppose you want to compile this. So Java C, ABS demo and run this. Now this is concrete method. This is concrete method, that is show is the concrete method. And next one is display is the abstract method. Display is the abstract method. So that this is the output for this program. Okay. Now, as we discussed earlier, we cannot instantiate abstract classes. Okay, now let us check what is abstract class here. A is an abstract class. Now I am trying to create object for abstract class, that is A equal to new A. Now I am trying to create object for an abstract class. Now let us compile this code and see what happened. Okay. Now here A is abstract. Okay, I'm getting an error, compile time error. What is that error? Error. What is that error is? A is abstract, so that it cannot be instantiated. Cannot be instantiated. That is, if it is an abstract class, so we cannot instantiate it. We cannot instantiate it. Okay. So that this statement raise a compile time error. Okay. So remove this. And similarly, this class is declared as an abstract class. This class is declared as an abstract class. So that include one abstract method. Okay. Suppose I am removing this abstract keyword. I am removing this abstract keyword and writing abstract void display. Writing one method abstract void display. Okay. Now let us compile this code and see what happens. Now Java C. Okay, Java C and compile the code abs-demo.java. Now this will raise an error. This will raise an error. What is that error? Now A is not abstract, so that it does not override abstract method display. Okay, because class A is not an abstract method, so that it does not include abstract method, that is display. Okay, so that if a method contains at least one abstract method, if a class contains at least one abstract method, then it must be declared as abstract class. Okay, this is the point you have to remember. Okay, practically you have to test it. Okay. So next, another point is abstract class contains some abstract class also includes constructors. Okay, abstract class contains some constructors. So now let us include one constructor here. Suppose int a comma b I am writing here, and then add one constructor. The constructor takes two variables arguments, that is int x comma int y. I am writing a equal to x and b equal to y. This is the initialization. The purpose of the constructor is initialization. Okay, now I am writing one abstract method here. What is that abstract method? Add. Where add is an abstract method. It is used to add the values of A and B. Okay. So in class B, what we should do is write one constructor int x comma int y. Okay. Now this constructor is going to invoke the superclass constructor. Super of x comma y. Then provide the implementation for the abstract method. What is the abstract method? Int, that is add method. So now this method provides an implementation. System dot out dot print ln. So addition is okay. So now we can add A and B here. Okay, add A and B. Then all the method b dot add after creation of the object. Okay. Now see here what happened. B int x comma int y. When you call this super, now the constructor is going to pass the values of x and y to the constructor of A. That is base class constructor will be invoked. What is its base class? A. Super class is A. So that x is initialized to A, y is assigned to b, so that a and b have been initialized. Now b, anyhow b is having access to a and b, so that b can access a values of a and b. So a and b will be added here. Okay. Couple 2, 5 and 7. The values of a and b will be assigned to x and y, and in turn a and b, then we will get a and b by addition of a and b using the abstract mapping. So this is 62. 55 plus 7, that is 62. We got 62 as the result. Okay. So this is how we are going to invoke the constructor, that is use of the constructor. Use of constructor in abstract class. Okay. So this is one simple example. The use of this abstract class. Okay. So now let us take one abstract class, that is a figure. Now here I want to use two variables. So double dimension 1 and dimension 2, and one method called double, one abstract method, right? One abstract method, a double area. This is one abstract method. Okay. One abstract method. So double dimension 1 and dimension 2 are the two different variables, dm1 and dm2, and one abstract method called area. Abstract method called area, right? So now let us take two subclasses. So now we need to initialize this dimension 1 and dimension 2. Okay. Using the constructor. Let us write one constructor for this figure. So double D1, comma, double D2. Okay. So here D1 is equal to D1 and dimension 2 is equal to D2. Okay. So this is the constructor which is going to initialize. Now here what you have to do is let us take one a rectangle class. This rectangle class extends the figure class. Okay. Rectangle extends figure. So now here what you have to do is let us write one constructor. This constructor is going to invoke the derived class constructor, base class constructor. So this is D1 comma D2. Okay. So double D1 and D2, then simply pass over of D1, D2. Now this is going to initialize dimension 1 and dimension. Okay. So then double area. Now this is going to return area of rectangle. Dimension 1 star dimension 2. Suppose dimension 1 star dimension 2. Okay. So then create object for this class rectangle RECT. So let us instantiate this rect R is equal to new rect. Now the constructor rect takes how many parameters? Two arguments you have to pass. Then R dot area. Invoke R dot area. Okay. Now this method is going to call the area version of this the rectangle class, and this returns dimension 1 and dimension am1 star am2, so that we need to handle it. We should take these values, so that use this print statement, and inside this print statement call this. Okay. Dimension 1 star dimension. Okay, so now let us compile this code and run this. Now dimension 1 star dimension 34 star 5, that is 20. Okay, so you got 20 as the result. Okay, so likewise, what we can do is we can write another class, suppose circle. We can write another class circle. So now this circle class consists of one constructor dm1 and dm2, and this is going to return dimension 1 star dimension 2 divided by 2, suppose. So like that, what I have to do is instantiate this circle class. Circle C is equal to circle. So this is circle C is equal to new circle of. So you can pass this 49 into 5 system dot out dot println, and this is C dot area. C dot area. Now this is going to calculate the area of the circle. Okay. So this is 122.5. This is area of rectangle and this area of circle. Okay. So here this area method is common. This area method is common for both the rectangle class and the circle class. Now both can provide different implementations. Okay. So both can reuse this shared abstract class. Okay. So this is the way to use this abstract classes. It's the way of using abstract class and its constructors. Okay. So this is about the concept of abstract class. So and finally, let us see the differences between abstract class and the interfaces. So this is the example program. So you can go through this example. And finally, let us see about these differences between abstract classes and the interfaces. This is the last one related to this abstract classes. Okay. So you know what is the keyword used to define the abstract and the interfaces. Okay. So what is the keyword? You can go for this abstract class means use the keyword abstract, and interfaces means use the keyword interface. So this is the first difference. And second one is what is the purpose of this abstract class in the interfaces. Okay. Now the purpose of this abstract class is to provide a common base class with shared implementations. Common base class with shared implementations like our figure class. Okay. So now the rectangle and circle which comes under the figure or the shape class. Okay. And okay. Next methods, coming to these methods. So now we can have abstract and concrete methods in the abstract classes. Okay, if you consider this abstract class, so now we can have both abstract and non-abstract methods. Abstract and non-abstract methods. Non-abstract in the sense concrete methods are a method with full implementations. So as we have seen here in the earlier case, okay. So methods consist of full implementations or abstract methods, that is in abstract classes. So whereas in interfaces can have abstract methods as well as default and static methods with implementation. Okay. Default and static methods with implementation. This is from Java 8 onwards. Okay. So this provision is there from Java 8 onwards. That is the default methods and the static methods with implementations. These two are the concrete methods. Okay. With implementation we can add. So this is regarding with respect to the methods. So abstract classes can have both abstract and concrete methods. So here also interfaces can default keyword of static keyword. Okay. Next, coming to the variables, the next parameter is the variables. Now, in abstract classes, so it can have instance variables. Okay, abstract classes can have instance variables with any access modifier like public, private, and protected. So, but whereas in interfaces, so only public, static, and final variables are there. Only public, static, and final variables are there. So, moreover, these are constants implicitly. The variables in interfaces are by default constants. Okay, because they are final static. Obviously, it is implicitly constants. Okay, this is with respect to the variables parameters. We consider the parameter variables. Next one is the multiple inheritance. Coming to the multiple inheritance, so it will not be supported by using even abstract classes also, not supported by the concept of abstract classes. So because a class can extend only one class, that is at most one class, so that we cannot implement multiple inheritance using abstract classes. So whereas using interfaces can implement multiple inheritance. So multiple inheritance can be supported by interfaces. This is regarding the inheritance. And next, coming to the constructor. So abstract class can have a constructor, as we have seen. Two examples I have seen, gone through that. So in both the cases, constructor is there, so that abstract classes can have constructors. So that, whereas interfaces cannot have constructors. So next, coming to the access modifiers. So you can use either public, private, or protected access modifiers along with the variables or methods in abstract classes. So whereas in interfaces, by default, all methods and variables are implicitly public. All methods are implicitly public. So as we have seen here, all are public. So by default, public. So next one is the instantiation. So you cannot instantiate abstract classes. Abstract classes cannot be instantiated directly. Okay. Abstract classes cannot be instantiated directly. That is, you cannot create object for an abstract class. So now we have seen also practically we verified. So this cannot be achieved. So similarly, these interfaces also cannot be instantiated so directly. Okay. So however, you can pass a reference to this class. So next inheritance relationship. So use when classes are closely related. When you are going to use this concept of abstract classes. So when the classes are closely related. So go for these abstract classes and use when classes may be unrelated but share some behavior. So go for the interfaces when use classes may be unrelated but share some common behaviors. Okay, these are the differences between abstract classes and the interfaces. Abstract classes and interfaces. Right. So this is about concept of abstract classes. Okay. So how to define an abstract class and how to implement an abstract class. So and what are the differences between the interfaces and the abstract classes. So this is what we have discussed.